for joining us today for our webinar, Connecting Tomorrow's Digital Buildings, sponsored by Panduit. You are among a small audience that we handpicked to be here today as we discuss single-pair Ethernet, a new technology that could change the way devices are connecting in buildings in the not-so-distant future. I am Jane Kacharzik with Panduit, and I will be facilitating this call. Just a little housekeeping before we begin. This webinar is being recorded. It will be available soon on demand, and registrants will receive an email when it becomes available. All lines will be muted during the webinar. Copy of today's webinar will be located on the handout section of your GoToWebinar dashboard. Following the webinar, there will be a question and answer session. Please feel free to submit your questions utilizing the chat box on the GoToWebinar app. We will answer as many questions today in the time provided. There will be a brief survey after the webinar concludes. We would appreciate your feedback. Today's presenter, Frank Straka, Product Line Manager for Copper Products in Panduit's Enterprise Business. He joined Panduit as an engineer more than 12 years ago and has been part of the development of many of the innovative products that Panduit sells today. He holds 29 patents in copper connectivity and cable design. Frank is active in the TIA TR42.7 standards group, which is developing new standards to support new applications like higher power PoE and single pair Ethernet. He is a frequent speaker at industry conferences on new copper development. Frank holds an MBA from Northwestern University, a master's degree from Syracuse University, and he received his bachelor's degree from the University of Notre Dame. This will conclude the introduction portion of the call. Frank, I'm going to go ahead and hand the call over to you.
Thank you, Jane, and thank you for everyone for spending some time to listen to me talk about some of these new developments. So today, I'm going to focus on a new technology that some of you may or may not be aware of called single-pair Ethernet. And at Panduit, we think it's a very interesting new technology that's out there. We think it has a lot of advantages for really wiring up the buildings of tomorrow. And today I'm going to cover a little bit about what the technology is and how we see it being used and deployed. So again, if there's any questions, please fill out in the boxes, and we'll do our best to either answer them on this call or get back to you at a later time. So with that, kind of going into just a little technology history. What determines what platforms survive, acceptance and focus, scalability and adaptability, and economy. And you look at all these other technologies that have been out there in the past, right? I mean, I think some of these, I know Panduit dabbled a bit in InfiniBand and looked at these other things, but they've all eventually went away. And then, we have technologies like PoE, HDMI that have really become dominant. Obviously, Ethernet's a big one too. That goes without saying. And now, here today to talk about single-pair Ethernet. And so, when you look at what the potential of the market is and what we're talking about, is when you look at Panduit's world headquarters building. There's 600,000 feet of standard 4-pair cabling. It was all Category 6A copper twisted pair cabling. There's about 500,000 feet of 2-wire. So that's, your HVAC, your lighting control, access control. And a lot of those different 2-wire systems were all, either really basic wiring, kind of homebrew, not really standardized systems, versus all the 4-pair stuff that was done with a standardized interface, standardized structured cabling. And, at Panduit, obviously, we're very invested in within that 600,000 feet and understand the advantages of going with a system like that has. Just to give people a little perspective of all the different devices out there in the market today where we see the applications for this, these are just a few examples. But anything that right now that's connected could be a potential. So you see here pictures of lighting, of cameras, motion sensors, temperature controls, within a room, temperature monitors, switches. Everything out here today is potential, and a lot of these different devices are all connected can be connected in very different ways. The lighting example we're showing there is connected through standard 4-pair cabling, and the switch is a standard 4-pair switch. But a lot of these other devices I'm showing here, these different temperature controls or these temperature sensors, they're not connected today with 4-pair cable, and there's reasons for that. Whether it's the putting an RJ45 on there is too big, or it's just not viewed as necessarily cost effective to do it. So there's a lot of good reasons and a lot of good ways to offer something new like single pair that could help with putting ports on these devices. So the agenda, talk a little bit specifically about single pair Ethernet, talk about the advantages of structured cabling, and then just give some of the views that Panduit has as to why to adopt single pair Ethernet. So at a high level, what is single pair Ethernet? Well, traditional Ethernet cables, that's your category 5E, 6, and 6A, use 4 pairs, and there's a picture of it over there, and they use an RJ45 jack with 8 pins. Single pair Ethernet, it's what the name sounds like, right? It's a single wire in a cable jacket. It uses only 1 pair, and it utilizes new connectivity. So rather than having room for 4 different contacts in the connector, it has only 1 pair. And that gives the advantage of making this connector down here, and it's not to scale relative to the RJ45, of being much smaller and much skinnier than the standard plugs out there. There's also a lot of work going on, and I'm not sure if anyone on this call has been involved in these or not, but you can see there's a ton of stuff going on with single pair Ethernet. There's industrial and automotive work being done today. There's a 15-meter automotive group, a 40-meter industrial group. There's standards to develop 100 megabits per second up to 15 meters, 10 megabits per second up to 1 kilometer. There's a poodle work being done, power over data lines. And then there's 2 down here that are actually somewhat specific to what I'm talking about, where work's being done with a focus on using single balanced twisted pair cabling within an enterprise or building. And one of the points I always like to make on this is a big hurdle for adoption of new cabling standards is whether or not there's actually going to be hardware for it, whether it's the chipset, whether it's the different types of devices there. And a lot of the thought process and about reasons why people have been talking about single pair within the enterprise has to do with a lot of that hardware work is happening. It's happening for the automotive and in the industrial spaces. So the view then is that work can then translate over into the enterprise market. So that's the thought process as to what's going on. And again, there's just a ton of work going on right now, at least in the standards bodies, with respect to single pair Ethernet. So, kind of re-summarize the points there, right? Single pair Ethernet is happening. What does that mean? That means things are being developed today. And then can we take that and bring it into the enterprise? And this is essentially Panduit's vision for connected buildings. And when we talk to, as a cabling company, we talk to a lot of people about connected buildings. And one of the common things we often get asked is, how do you do it? How do you get all these different systems to talk to each other? How do we manage it? So there's a lot of questions, a lot of unknowns on connected buildings today. And, some of the obstacles we see on it are that certain systems are not yet on it. There's many different ways people want to adopt it, or adapt to it. There's many different, visions. Do you want to go wired or wireless? Do you want to have, you have some systems where every single device has a port on it. Some of them have like a centralized management structure where it all connects. And how do you get those different systems to interconnect? And there's a lot of variability in requirements. There's some devices that want a lot of power and some that don't want a lot of power. There's higher data like an access point and lower data, say like a little sensor. And then there's long reach versus short reach. And the vision, right? One unifying interoperable cable and connectivity system to connect everything. And where does single pair fall in this? Well, it's lower power as it's only 1 wire, it's lower data, and it's longer reach. And that's different than what you're seeing today with the RJ45 systems. RJ45 systems are, 100-meter reach. it can have high data and have higher power. So here's a comparison of all the different standards out there for it. Right, with your standard 4-pair system, you can go up to 10 G-base-T. Now, single pair, it's up to 1 gig, but you're only looking at about 10 megabits per second at 1,000 meters. 4-pair, power levels up to 71 watts with PoE++. Single pair, up to 15 watts, but that's kind of a TBD right now as to where that can go. Reach, you're comparing 100 meters to 1,000 meters. Connector type, RJ45. Single pair. There's different connectivity options out there right now for single pair. Right now, the one we're showing here is a modified LC. And so you have a lot of advantages with going at like the path right now with the modified LCs. The LC connector is a proven connector design out in the market. The LC connector has been adopted by TIA and I believe in the IEEE as well as being a preferred connector type for this. And the LC has a lot of good factors relative to how you can use it. It's got a latch on there, so you can, get it into a port and make sure it stays in there. There's also push-pull designs on LCs, meaning that in a high-density application, you can actually kind of pull on the back of it, push it in, pull it out. So it can work in a lot of different environments. So, this has been a pretty recent development that this modified LC concept has gained a little bit more traction. We've been pretty excited about it. One of the nice advantages to using a different connector and something a lot different than an RJ45 is you do get more density. So when you look at a RJ45, you have 48 ports in one rack unit, whereas the LC you can fit 96 points in a single rack unit. So with that, Panduit does see the advantages there. When we talked about a lot of stuff like sensors and all those devices, they can be pretty small. So by having a device that is fundamentally a little skinnier, can be made a little shorter, it'll work well with those different types of applications. So now let's talk about structured cabling a little bit. And this is where Panduit has really seen some advantages of going with an approach like an LC type of connector. So the first question a lot of times people might ask, what is structured cabling? Well, it's basically a system. The easiest way to do it is compare it to what's a home run. A home run refers in our industry is that it's basically a single cable with connectors on the end of it. So for example, I've got a picture here of a switch going to a camera on the other end on the bottom of the screen. That's a home run. Two types of cabling systems. The standard says you can have up to 4 connectors in a system. That's shown on the left, or a 2-connector system shown on the right. And what does it get you with this, right? It gives you a lot of flexibility, first of all, with a structured cabling system. Rather than having to, imagine you need to move that camera, right? If you had to move that camera and that cable is not long enough, what do? You have to maybe pull another cable or add something, attach something to it or trim it or move it around. In a structured cabling system, there'll be certain, demarcation points along that system where then if all of a sudden, that last run of cable couldn't get to the camera, well, maybe you can just put a new cable in from that point, and that'll be much easier access. So a lot of times when you're trying to run cables through walls and everything like that, it can be extremely difficult to take a cable out or re-pull a new cable. A lot of times local codes and authorities do not like having unused cables sitting in the wall. So if you're not using a cable, they would say you need to pull it out. So having a structured cabling approach ensures that you're really putting in a cabling system that is designed to be future-proofed, designed for maximum flexibility, and really is good for moves, adds, and changes. Another thing that's nice about structured cabling and standardization is, it really gives people the flexibility to innovate and, and do a lot of neat things within a space. The RJ45 is an example of the success of standardization. The RJ45 began in 1987, and it has all these different data rates going on it, right? You can do 10 megabits, 100 megabits, 1,000 megabits, 10 gigabits per second. And you have 25 and 40 G-base-T coming soon. There's over 2 billion RJ45 ports that have been made. And it's been one of the most successful interfaces, ever. And when a lot of times when we talk about standardized structured cabling, right, we're talking about a generic cabling solution. And a generic cabling solution refers to the fact that the cabling is designed to meet a set of standards. And it's not necessarily specifically designed around any type of application. A lot of these systems are, in a sense, designed around a specific application, but a cabling system, when you go and test in the market, you're actually testing it for a lot of cabling parameters like loss, reflections, noise, crosstalk, and you're not actually running data over it to ensure it meets the data. And that's kind of a good point to make, because by making these things generic, it allows for a lot of innovation in that space, and you're not tying it to a specific vendor or type of device. So it allows people the flexibility to innovate. A lot of times these cabling systems in buildings can last 25 years or more. And by having these generic cabling systems is that you can connect new devices to 25-year-old cables. It allows a lot of innovation in the space. And the point with that is that when you look at a simplified and standardized interface, right? These days we're kind of moving to like dongle hell, right? We have a lot of these different devices being plugged in and adapted, and you've got to, if you want to connect an RJ45 to some computers or a USB, you actually have to take a USB-C port, add a dongle to it, add a device. I remember when Apple went to their Lightning connector, right? All of a sudden you had all these old connectors in your house that were no longer useful anymore. And that creates some, difficulty. But, when you're talking about a single consumer, a single individual, that's a little bit easier to manage. Now, if you imagine a commercial building that might have tons of different ports on there, if all of a sudden the interface has changed, that can create difficulties and stress. So what I'm trying to say by all this is that by having a simplified and standardized interface of an LC connector, that part has been decided then, right? The LC connector, we know it's a high bandwidth solution. We know it can support power. And then all that innovation and stuff can actually occur on the product side, not having to worry about how you can connect it to your cabling system. And if we think about all the different devices today that now run off an RJ45, you have, back in the day, right, you were effectively connecting servers and switches and computers to the network, and then it expanded to more, say, like IP phones, and you have cameras, and now access points, and just all sorts of these different devices that are now coming onto the network that people can really put whatever they want, because they know if they put an RJ45 port on the device, they can connect it to anything on that network. And that, I think, gives a lot of advantages to why these standards have been so successful. And that's why a lot of these things, when we're talking about the LC, it's so important that people adopt a standardized interface, because it gives, the thing that people really care about in the building, right? I'm a cabling guy. I would love to think people really care that it's a LC, connector on the back side of it, but nobody knows that. All people know is that, hey, they've got this really cool new display, or they've got this cool new lighting system. And that's all being run through a standardized cabling system. And right, so some of my notes down here too: standardization eliminates proprietary and non-compatible interface. It also gives you confidence to deploy for performance and safety. So you know that by putting in a standardized interface, like something like an RJ45 that has stood the test of time, or an LC interface that has been around in fiber now for a long, long time, you know that you're getting a very high-performing, very safe type of cabling system to use on it. So, right, and then again, to go with structured cabling and standardization advantages, they're easily scalable and flexible. Well-designed networks can be easily upgraded and new areas added. Structured cabling is often shown as a good thing for, say, an open office, or if you need to suddenly move stuff around, structured cabling can easily accommodate that kind of thing. Reduced downtime. This is something we hear a lot, is that the number one cause for problems on a network is the physical layer or the cabling layer. That's what causes, a lot of people to work with vendors like Panduit, where we can provide, higher quality structured cabling solutions and eliminate that, major cause of downtime. Simple, standardized solutions that are, widely available, can be easy to install. I mean, you develop an ecosystem of contractors and installers that fundamentally understand what the interface is. I mean, if anyone ever needed to go out and install a 4-pair cabling system today, there are countless number of people out there in the market today that can do it. Future-proof. I mean, I think this point we kind of spoke to a bit, a few minutes ago, where it's very easy then to upgrade equipment that have these standardized interfaces. So in essence, right, you can worry about what you want to do, not if your wiring can support it. And of course, safety, where products being designed, by somebody like Panduit and by to a specific standard are inherently safer. I mean, an example that pops into my mind is, again, I'm referring to Apple products here, but the Lightning connector that they developed in-house. I've had to replace I don't know how many of those because the interface near the connection gets frayed and gets damaged pretty easily. And then, now it finally looks like, there's a few more vendors out there developing products in the market. So by having these larger ecosystems and more vendors, the new ones that are coming out seem a little bit more robust. But, by having a variety of people out in the market and having a variety of vendors, inherently you get a much more robust and much more reliable solution. So, lastly, why adopt single-pair Ethernet? Beyond the reasons we said, well, today, right, there's a lot of support for single-pair. There's a lot of work being done in the IEEE, which some people on this call are probably more familiar than I am. It's been adopted by the TR 42.7 group. That's the Telecommunications Copper Cabling Systems group. It's also been worked on in the 42.9 group. That's the industrial group. And it's been, worked on by industry leaders. And I can say, what did my computer just do? So I can say that, Panduit and CommScope have, at, I believe, the IEEE meeting, have demonstrated interoperability. So multiple companies are working on this type of thing. And you can see here the Cabling Installation and Maintenance magazine has devoted time to it. Apologize for this. I don't know what my computer is doing. Standardized interface. So again, referring back to this LC connector, right? This LC design has been adopted in the IEEE and the TIA. It looks a lot like that LC fiber interface. So a lot of the latching and everything else is the same. Obviously, because it's a copper interface, it is a little different. You can kind of see there's two little pinholes on the bottom there. That is how you interface to the equipment. There's been a lot of testing done on the interface to ensure that those little copper interfaces are able to accommodate both data and power and go up to the higher bandwidth that the standard is asking for. So to the point, it's battle tested and proven, and allows for simple upgrading. I'm talking about upgrading in the future, right? You put in a single pair interface in the building and you decide to standardize across it around all the lighting, all the sensors, all the devices, and you find out in 3 years that, hey, these really cool new sensors that do all this other neat stuff to it. By having a standardized interface around all that, it's as simple as going out, buying the new sensors, unhooking the old ones, plugging the new ones in, and it's a very easy and simple upgrade. So you worry about the features you want at the end device, not how you're going to connect to it. So that's the advantages we've always seen with the RJ45. Field termination of single pair. A common question that people will ask on a structured cabling solution is, can you terminate it in the field, right? So that's versus a pre-terminated. So when you're laying out your cables, you basically can cut it to the length you need. The picture I have up there is what's called a service loop, meaning that someone, maybe they needed 100 feet and they bought 130 feet of cable. And that can be more common in fiber optics where people don't always want to do the field terminations on site. So the nice thing with single pair is it's designed for field termination. This means that you can customize the exact length you need, and it will be very similar to terminate to how RJ45s are out in the field today. This means that there's a large contractor base already out there today that's familiar with structured cabling, that's familiar with the companies that are working on this, and they'll be able to do all these installations, basically the day we launch these types of products. So there's already a large ecosystem out it, and there's a lot of people out there that for field termination can be a pretty big deal. So, kind of wrapping up here a bit and summarizing, is that with single pair, right, it's a bandwidth up to 600 megahertz. It's a length up to 1,000 meters. So we are talking about something that is fundamentally unique and different than what's out there in the market today that's limited to 100 meters. This new standard is capable of handling both data and power. It's easily customizable in terms of lengths, in terms of how you deploy it and number of connections. And there's a large structured cable industry ready to support it. Not just from the vendors like Panduit, but also people that are familiar with installing structured cabling out into the field today. And this is just a list of single pair companies that are out there. This list was taken from people that have been participating in the IEEE meetings. So we basically went out there and looked at who is going into these IEEE meetings, who is contributing, who is on the list, and these were the different companies that were represented by the individuals going to those meetings. So there's been significant interest out there really across the board on equipment, chips, cables, etc. So thank you again for your time, and throw it back to you, Jane.
Okay. Thanks, Frank. We will use this time to answer questions. Please feel free to submit any questions on the chat box in the GoToWebinar app. We will give it just a few moments, Frank, for some questions to come in. Okay, it looks like I have my first question here. What would be the expected price point of a single pair cabling system versus a 4-pair cabling system?
It's still a little early at this time to estimate, but you're fundamentally going from 4 pairs down to a single pair system. Our rough estimates right now is that just from the cabling standpoint is that it would probably be about a third the price, not a quarter, but a third, because there's still some commonality in the elements, but it should be a little bit more cost effective there.
Okay. Looks like one more question here. Are any enterprise devices using single pair Ethernet today?
Unfortunately not. Like I said, this meeting was more or less to talk about the future. So when you get out there in the market today and in the enterprise today, nothing is using the specific single pair Ethernet technology we talk about. There's a lot of devices connected, into the Ethernet, but nothing using single pair.
We want to thank you for your questions and your time today, and would also appreciate your feedback on the survey. Thank you and have a great day.